All right, save that. All right. Sample round problem 4, traversing the country. Difficulty rating 1. Your team is about to return from their mission and they need you to complete one more task for them. Your summer vacation is right around the corner. Today you're working on navigation. You've received a file containing a list of paths between key locations to visit. Ooh, we're going to do pathfinding. They explained the following to you. Each location is represented by a unique code made up of 3 uppercase letters. Each unique path is represented by one line of the file. Every path in the file can be crossed in both directions. Okay. Before you begin, you probably should know the number of unique locations that are listed in your file. All right, let's get our puzzle input. Problem 4. Okay, looks like there's 75 total edges, but all we care about for the first part is how many unique locations there are. Okay. I imagine it's part 2 and 3 are going to be traversing the edges, but if we just need to know the unique edges, we can grab it from hash set, right? Let locations equals hash set new. For line in lines, let left right is equal to line split once on this unwrap. And then we can say locations insert left, locations insert right. That way we don't have to care about unicifying it. We just let the hash set do that for us, and then println part 1 is equal to locations len. We need to pull that in. And our answer is 45. Is it correct, though? It is. Yay. So we are now doing git add source, git commit -am problem 4. It's called traversing the country, part 1. All right, is part 2 actually following edges? Ooh, difficulty rating 3. Now that all the different locations on the map are identified, you're probably ready to continue. The following information is given to you. The starting point is represented by the letter code STT, and all of your team's vehicles start at this location. It's assumed that moving across any given route will always take 1 hour of time. Okay. Your team claims they are on quite a tight schedule, and so they can only spend at most 3 hours traveling to a destination. You are tasked with determining the number of different locations, including the starting point, that they can reach from the starting location in at most 3 hours. All right, so we can reach the starting point. We can reach anything the starting point connects to. In this case, it's just one location. And then anything that starting point connects to, and anything those locations connect to. So 1, 2, 3, 4, 5, 6 for this puzzle input. All right, so we start with STT. So now we actually need the edges. Should I make a struct for it? Sure. Left, right. And then what we'll do is we'll convert these into edges. Let edges equals lines, iter, map, edge, edge, parse, edge, unwrap, collect, vec. Okay. And now we need to write a parser for it. Impl for edge string. Actually, we could just say unit. I'll just panic if it fails to parse, and we can just do the same thing here we did up above. Left, right equals s split once on that field separator. And then we're just going to convert them to strings. Okay. Self, left, left to string, right, right to string. I probably can just do into. Yep. And then, well, let's convert part 1 to use the edges so we don't resplit it each time. Edge in edges, edge left, edge right, and we probably have to clone them. We still have 45 for the answer for the first one. Very good. So now part 2 is we're going to start at STT. I guess we could just use a regular breadth first search, right? New Q insert. We're going to start with STT at a distance time of 0 hours. We also need visited, right? And we can say while let some location and time is equal to, oh, this is, sorry, it's a vecdec. We're going to say push back, pop front. If time is greater than 3, we're done. So therefore time is less than or equal to 3. That's fine. And then we can just visited insert. In other words, we haven't visited this location yet. We're going to get the neighbor. Oh, yeah. You know what we need to do? We need to do a hash map here. Yeah, we need to do a hash map from string to string. No, from string to hash set of string, right? Because we want it from location. From any location, you can go to multiple other locations, right? Because NYC can go to STT, ADB, or JLI. So we need a set of all the strings we can go to. So locations should be locations, entry of edge, left, clone, or default, insert, edge, right, clone. And then we do the same thing the other way. It's still locations len, right? Oh, we need to pull in hash map and vecdec to get it to compile. Yeah, it's still 45. So we still have the length correct. But now we need to grab all of the neighbors of lock, which we get from looking up locations here. So for neighbor in locations of lock, right? And this should be a hash set. This should be the hash set, and this should be the entry in the hash set. And it's a little confusing, but I think this is a string, and we'll find out in a second. Q push back, neighbor clone, and time plus 1. And then part 2 is just going to be the number of places we visited. Oops. This needs to be a tuple. And it doesn't build. Oh, I need to do this. This is a stir. Oh, it's a stir. I should make this a 2-string. I'm moving the value there. Yeah, it's saying borrow here, but I can't borrow here. Oh, because, got it. I'm inserting it here. 10. That seems small, but let's find out if it's right. Oh, it is right. How about that? Okay, that wasn't too bad. Problem 4, part 2. What's part 3? Part 3, difficulty rating 3 also. It looks like your team is quite dismayed with this result. They couldn't seem to reach the optimum number of locations with a time limit of 3 hours with the planned paths, which also happen to be the roads with the cheapest fees. What a coincidence. So after a brief period of scheming, they make a slight change of plans. For every location on the map that can be reached from the starting point, exactly one distinct vehicle is sent to travel to that location from the starting point. So 45 vehicles. Each driver is willing to travel for as long as necessary to reach a reachable location. All drivers will take the shortest route from the starting point to their destination. Due to their new plan, you are now tasked with finding the total number of hours that all the vehicles will spend traveling to their destinations. Oh. Okay, so now we just do a full search. Instead of stopping after 3, we do a full search, but we add up all the time we take. Okay. I mean, that doesn't seem too bad, right? If we just copy paste all of this, we get rid of the time consideration. We say let total time equals 0. Total time plus equals time. Right? And then part 3 is just going to be the total time. I'm going to quit out of this in case I have a bug in my code. Well, we got the answer 203. I have no idea if it's right, but at least we have an answer as opposed to an infinite loop. And it's the right answer. Okay. That wasn't too bad. I like these difficulty 3 problems. Let's commit that change. And that actually finishes up. Oh, let's read this. After helping your team navigate the country, you can't help but feel the urge to call them out for their "we're totally on a mission" summer parties. Time to do a little scheming of your own. All right, and if we go back to the challenges.